Okay, so I'm going to go through a couple of the review problems with you, one of each type. Your review starts on page 113. 113 has some linear functions in slope-intercept form. So I'm going to go through one of these with you. So if you get stuck on the other one, it's going to be the same type of problem as this one. So for number one, here's our function, negative 3x plus 4. Our slope is negative 3, and our y-intercept is 4. That's the information we get from slope-intercept form, okay? So I can create my graph from the y-intercept and the slope. I'm going to plot my y-intercept, which is up at 4, and then I'm going to use my slope to get some more points on this graph. Remember, slope is rise over run. Our slope is negative 3. That means our rise is going to go down 3 since it's negative, and our run will be 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. Always at least 3 points. I'm also asking for a table of values here, so I'm going to do some extra points. That way I know I have enough points for my table. Anytime I give you a table, I expect you to fill the table, okay? Not a couple of points and leave the rest blank. If I give you a table and it's got 5 spots in it, I want 5 ordered pairs. 1, 2, 3 over 1, and I'll do 1 back this way. 1, 2, 3, back 1. I got my points. Since we're graphing a function, I'm now going to connect these points and throw arrows on the end. When you graph on your quiz, I'm going to look for at least 3 points. I'm going to look for those points to be accurate, connected, and have arrows at the end. So now that I've got my points, I'm going to go ahead and throw some of these values into my table for another representation of this function. So here I've got the point negative 1, comma, 1, 2, 3, 4, 5, 6, 7. I know the point 0, comma 4 is on my graph because that was my y-intercept. I get the point 1, comma 1. I have the point 2, comma negative 2. And I have the point 3, comma negative 5. So that's graphing from slope-intercept form. On the next page, we have point slope form. I'm going to go through the second of these. I'm going to go through number 4 with you down here. So for point slope form, I know the point and the slope. Our starting point comes from here and here. Remember that x value for my ordered pair has the opposite sign of what I see in parentheses of x. So I have the point 6, comma 2. My slope is in front here. I just see a negative sign. That means that my slope is negative 1. I cannot see my y-intercept from the function. I'll have to get that from my graph here in just a minute. I could also plug in 0 for x and solve to get the y-intercept. I'm going to try and get it from my graph. Since I have to graph anyway, I'm going to try to get my y-intercept from my graph. I've got a point and a slope, so I'm going to plot my point, 6, comma 2, and my slope is negative 1. So remember, slope is rise over run. Since my slope is negative 1, negative means my rise will be down, and my run will just be 1. Remember, always run forward. So down 1, forward 1. Now I'm out of space on my graph, so I'm going to reverse those slope directions to get points back here. So up 1, back 1, up 1, back 1. And I'm going to keep going until I hit the y-axis so I can see my y-intercept. Always a minimum of 3 points. I did more here because I wanted to see the y-intercept. Minimum of 3 points. Once you've plotted your points, connect them, throw your arrows on the end. My y-intercept here would be, there's 5, 6, 7, 8. My y-intercept is at 8, or if you wanted to write it as an ordered pair, 0, comma 8. And then some points for my table. I'm going to go ahead and put my y-intercept in there. Then I would also have the point 1, comma 7, 2, comma 6, 3, comma 5. And I could keep going. I'm going to go ahead and put my starting point in my table. I got that one from my function, so I know that that one's correct. So that one in my table too. So that's graphing from point slope form. Remember, we get a point and the slope from point slope form. The last format for a linear function equation that we talked about was standard form. So we'll take a look at standard form. That's on page 115. We'll take a look at this first equation here. We had two options that we looked at for graphing from standard form. The first was to change it to slope-intercept form. The other option was to find the x and y intercept from the function. I'm going to go through both options. Remember, you only need to do one of those options and then create your graph. Okay, I'm going to do both so that whichever you prefer, you can see. If you are a change to slope-intercept person, then this is for you. So our function starts off 5x minus 2y equals 10. To change to slope-intercept form, I need to get the y by itself. So I'm going to start by moving this x term to the other side. I have to subtract 5x from both sides. So I'm left with negative 2y equals negative 5x plus 10. Remember, we don't combine these because they are not like terms. Now my next step to get y by itself is to divide everything by negative 2. So I'm dividing each term by negative 2. That leaves me with y equals negative divided by a negative is a positive, but 5 over 2 doesn't reduce completely. Those don't divide evenly. And since this is going to be my slope, I don't want to write it as a decimal. So I'm just going to leave that as 5 over 2x. And then 10 divided by negative 2 is negative 5. So there's my slope-intercept version. And then really quickly, I'm also going to do the x and y intercept version. So remember, to find our x-intercept, we're going to plug in y equals 0. So that would be 5x minus 2 times 0 equals 10. Negative 2 times 0 is just 0. So I'm left with 5x equals negative 10. Divide both sides by 5. And we get x to be 2. So we have an x-intercept at 2. The point 2 comma 0 is on my graph. To find my y-intercept, I'm going to plug in x equals 0. So this would be 5 times 0 minus 2y equals 10. 5 times 0 is just 0, so I'm left with negative 2y equals 10. To get y by itself, I'm going to divide both sides by negative 2. So I get y equals negative 5. So I have the point 0 comma negative 5 on my graph. Notice that this matches my y-intercept from slope-intercept form. So my x-intercept is 2, my y-intercept is negative 5, and my slope, which I can get from slope-intercept form, is 5 over 2. If you are going to graph from slope-intercept form, remember that means you're going to plot your y-intercept and use your slope to find more points. So this says up 5 over 2, up 5 over 2. If you are graphing by finding the intercepts, then you wouldn't know your slope yet. You're going to start by plotting your x-intercept and your y-intercept, and then count to find the slope. So 1, 2, 3, 4, 5, up 5 over 2. So you would get your slope from plotting your intercepts and then counting. And then you can give me another point by going up 1, 2, 3, 4, 5 over 2. You're going to get the same points no matter which way you graph. You're just going to get them in a little bit different way. And then once you've got at least 3 points, connect them and throw your arrows on the end. Now I'm going to go ahead and throw the points I know into my table. So I know the point 0 comma negative 5. I know the point 2 comma 0. I know the point that's 4 comma 5. And then I need 2 more points here. Okay, so to get 2 more points, you can sort of sketch where the next one will be on your graph. The one that's sort of just off the table, you can find fairly easily. So we're going to go up 1, 2, 3, 4, 5 over 1, 2. So this would be, there's 5, 6, 7, 8, 9, 10. This is the point 10 comma 6. If I wanted, reverse that, 6 comma 10, sorry, x comma y. 6 comma 10. If I wanted another point, which I do, because I've got a spot left in my table, if I wanted another point, I can plug in a value for X and see what I get for Y. So you can plug in to standard form if you want. You can plug into your slope-intercept form if you want. I'm going to choose to plug into slope-intercept form, and I'm going to pick an even number because my slope is 5/2. That means I'm going to have to multiply by 5 and divide by 2. So if I pick an even number, I'll get a whole number for my Y value. So we've got 6. How about 8? So that would be 5/2 times 8 minus 5. So I'm going to divide first just to make my work easier. 8 divided by 2 would be 4. 5 times 4 is 20. 20 minus 5 would be 15. So 8 comma 15. That's going to be off my graph, but that's okay. The last thing that you're going to see in your review are some of those word problems. So that's what we'll take a look at next. So on the next page, there are 2 different context problems for you. Let's take a look at this bottom one. The one at the top is pretty similar to what we worked on last week with our standard form function. So let's take a look at the bottom one since we haven't done one like that in a little while. The fish tank is draining at a rate of 1 gallon every 2 minutes. Rate is a slope. So I know my slope would be 1 gallon every 2 minutes. And since we're draining, I want that slope to be negative. And then after 4 minutes, there are 3 gallons remaining. That's a point. After 4 minutes, there are 3 gallons remaining. So I'm going to make my X, since my graph isn't labeled yet, I'm going to make my X my time, my minutes, since we started draining, and I'll make my Y the gallons. So my line would look like Y equals negative 1/2 times X minus 4 plus 3. I'm going to graph my function. So I've got the point 4 comma 3 on my graph. My slope is negative 1/2. So I lose a gallon every 2 minutes, lose a gallon every 2 minutes, lose a gallon every 2 minutes. From here, I can see my y-intercept is 10. On the y-axis, we're looking at how many gallons we would have versus time. So this is telling me at 10 minutes, we have 0 gallons. So the tub, I think, or tank, we're draining a fish tank. The tank is empty at 10 minutes. Or the tank has 0 gallons after 10 minutes. To find my x-intercept, I need to plot some points back this way. So I'm going to reverse that slope, up 1, back 2, up 1, back 2. Now that I've got all my points plotted, I'm going to go ahead and connect these. I'm not putting arrows on this one because I'm not just graphing a function. There's a context here. So I want to connect because I'm not going to hop between minutes, right? At some point, I'll have been draining this tank for 1.5 minutes or 2 minutes and 45 seconds. And I won't have only whole number amounts per gallon, but I don't want any arrows because I can't have less than 0 gallons in the tank. And it doesn't make sense to talk about time before we started draining. So connected, but no arrows on this one. I switched these. My x-intercept would be the tank is empty. At 10 minutes. Thought that was y-intercept up there. We're used to finding the y-intercept, not always the x-intercept. Okay, so my x-intercept is 10 because the tank is empty at 10 minutes. My y-intercept is 5. And this would be 5 gallons when our time is 0. So that means the tank had 5 gallons of water initially, or to start. I'm starting with 5 gallons of water in the tank before we started draining it. Okay, so that's one of each type of your review problems. Again, your review problems are pages 113 to 116. You have a little bit of everything in there.